This video is very helpful for all those who are in confusion on selecting the test to be done for convergence. Please watch this video and your confusion will be blown away. See here, this is the topic sequence and series. First of all, this is the geometrical series. So here, according to the geometrical series, it will be A plus R square and so on. This is the kind of the series. So we say that it's convergent if R value lies between -1 and 1 and diverges if R value is greater than or equal to 1, oscillates finitely if R is equal to 1 and oscillates infinitely if R less than -1. So these are the kind of the problems 1 by 3 power n, sigma 1 by 3 power n and sigma 1 by 2 power n. So these are the general questions which are asked. For finding the convergence, we have to select the geometrical series. So this is 1 by 3, so which is less than 1. So it's a convergent series. So it's 1 by 2, so 0.5. So the value here is less than 1. So the given series is convergent. If the question is this kind, so we have to go for geometrical series. And coming to the auxiliary test here, so this is the auxiliary series. See, 1 by n power p. So it might be 1 by n power 1, 2, 3, 4 and so on. So this is the series and this is the general term, that is summation of 1 by n power p. So according to the auxiliary series, so it is convergent if p is greater than 1. If the value of p is greater than 1, we say that the problem is convergent, and if p is less than or equal to 1, if it's 1 or even less than 1, then we say that it is divergent. So before testing this, we have to go with comparison test. If sigma un and vn are two series of positive terms and we have to make the limit n tends to infinity, un by vn is equal to L. If it's a finite value, then we say that sigma un and vn are both convergent or divergent. So these are interlinked. So first we have to make a comparison. First we have to find the auxiliary series. According to the auxiliary series, so we have to find whether it is convergent or divergent, and again by going through this comparison test, if it's a finite value, then we say that un and vn converges or diverges together. So these are the kind of the problems. So when you see, this is 2n minus 1 by n into n plus 1 into n plus 2. See, watch this video right till the end. So we have to choose vn. So for this question, this is un and we have to choose vn. So vn should be the number of n's in the numerator and the number of n's in the denominator. Here there is single n and there are 3 n's here. So this is 1 by n square. So here if p is greater than 1, so this 2 is greater than 1, therefore according to auxiliary series it is convergent. See here, 1 by 1 into 2 into 3, so this is the nth term here. So there is a single n and there are 3 n's here, so 1 by n square. So which is greater than 1? Convergent. See here, tan 1 by n. So we know that limit n tends to infinity, tan x by x is equal to 1. So I am choosing vn as 1 by n. So here it is 1. So if it's 1, it is divergent according to the p test or auxiliary series test. So this is divergent. So if in this case we have to make a rationalize it, that is n square plus 1 plus root over this is n square plus 1 by, so this is minus 1, this is root over n square plus 1 and plus this one is n square minus 1. So in the denominator we have n, so this is vn is equal to 1 by n power 1 divergent. So here also 1 by n square convergent. So here also we have to take 1 by n cube convergent. So we have to choose vn, and again we have to apply convergence comparison test un by vn, and this is convergent. So this is 1 by n cube. So here n we can cancel, and this is 1 by n cube. So this is greater than 1. 3 is greater than 1, convergent according to the p test. So here in this case also, so in numerator we have n power q, in the denominator we have n power p. So we can write as p minus 1. If p minus 1, this p minus 1 is greater than 1, then it is convergent. If it is less than or equal to 1, this is divergent. So these are all the set of the questions which we need to apply comparison test and p test. So this is, so u and we can take like this. So this is u1 and we have to opt vn. So vn is equal to, there are 2 n's here, n square. So there are 3 n's here. This is n cube. So after cancellation we got n power 1. So if it's 1 or less than 1, then it is divergent according to the p-test. So this is 1 by 2 power n, 3 power n. So here it is. So if I take 3 power n common, or Vn is equal to 1 by 3 power n. So 1 by 3. So this is less than 1 according to the geometrical series, as I said you the first test. So this is convergent. So log n by 2n cube minus 1. So here we have to choose Vn. So here there is single n and there are n cube. So this is n square. So this is p is greater than 1, convergent. And in this case also, so we have single n in the numerator and n power p in the denominator. That is n power p minus 1. We have to choose Vn. And again, it depends upon if p minus 1 is greater than 1, convergent. If it is less than or equal to 1, divergent. So in this case also, here we have to take Vn. There is nothing here. And in the denominator we have root n. Root n is nothing but half, which is less than 1, divergent. And here sine 1 by n. See, there is a logic here. So we have a limit un by Vn. So we have sin x by x is equal to 1. So in this case we need Vn as 1 by n. So limit x by x is equal to 1. So if it is 1, see here, so if it is 1, the test fails. Or we can say that sigma, un, vn both converge or diverge together. So sine square 1 by n. Here I'm taking n 1 by n for twice, 2. So p greater than 1, it is convergent. So in this case also, in the numerator we have n power n. In the denominator we have n power n plus 1. So after cancellation I got 1 by n power 1. So here 1. So p is equal to 1 or less than 1, then it's divergent according to the auxiliary test. So if it's un, see here I have to choose vn. N by, here it is n root n. After cancellation n power half. If it's less than 1, divergent. So here in this root over, in the numerator we have 1n. Here we have n power 5. So we have 1 by n square. So p greater than 1, convergent. If un is equal to, see here, this is, we have another limit, that is limit n tends to infinity, n power 1 by n is equal to 1. Therefore we say that sigma un, vn converge or diverge together. So these are the special cases. Un is equal to 1 by 2n minus 1 power p. Here we have to take vn as n power p. So it depends upon p. If p is greater than 1, convergent. If it is less than or equal to 1, divergent. So these are all the set of the questions from the text I have taken. And see here, so in this is the model, this is un. So vn we have to opt n square by, how many n's are there? N into n, n cube. So vn I have to take as 1 by n power 1. So this is 1. So we say that according to the p-test series, divergent. So here in this case, root over, half means root over, this is 2 power n, this is 3 power n. So r is equal to root over 2 by 3, it is less than 1. According to the geometrical series, it is convergent. So here in this case, so this is root over n square, the number of n's in the numerator by number of n's in the denominator, that is 1 by n square, convergent. And see, un is equal to, here 1 by n square, 2, it is greater than 1, convergent. So in this case also, in this it is of the form geometrical series, r is equal to half, less than 1. According to the geometrical series, it is convergent. So in this case, here in the numerator we have root n, in the denominator we have n square. So bringing half down, so we have n square minus half. So which is equal to, this is nothing but 3 by 2. So 3 by 2 is greater than 1, which is convergent according to the p-test series. Here in this case also, we have root n in the numerator and n square in the denominator. And same as it is, this is also n by 3 by 2. So which is greater than 1, convergent. So in this case also, so if I rationalize with plus on both sides. So here root n power 4, which is equal to n square, in the denominator remains 1 by n square. So 2 is greater than 1, convergent. And here in this case also 3 by 2, convergent. So here So all the questions in the textbook, I made a video. See here. So Vn is equal to, this is in the denominator we have 2 n's, 1 by n square. So 2, it is greater than 1, convergent. And in this case, n power 3 by 2, convergent. This is n cube and this is n power 5. If I cancel, this is n square, which is greater than 1, convergent. And this is also n power 3 by 2, which is greater than 1, convergent. And in this case also we have to choose Vn as 1 by n square, convergent. And in this case, if I rationalize, so in the denominator remains root n. So root n is nothing but n power half, which is less than or equal to 1. So this is divergent. So these are all the questions related to the p-test series or auxiliary series. See, look at these questions first of all. So this is un, there is no and so on, there is no factorials. Simply we have to take un and we have to select vn, we have to make a comparison test and directly we can write. So I made videos on all these problems. So see here, so these are all the questions. If you go through all these questions, you will have a clarity. If un is perfectly known, then we have to choose vn and we have to go with the p-test. See here, this is geometrical test. So here, these are all the questions. Please, all the questions I have given. So once you, if you go through these, un is very simple here. And see here, these are all the questions related to the p-test series. So after 30th. So make a note of this. If you see, un is very clear, vivid here, and we have to go with p-test series or auxiliary series. And next, coming to, see here, coming to this one, D'Alembert's ratio test. So when we have to use this D'Alembert's ratio test? So here, what is this D'Alembert's ratio test? If sigma un is a series of positive terms, then limit n tends to infinity, un by un plus 1 is equal to L. Then un converges if L greater than 1, un diverges if L less than or equal to 1. Same as p-test. If it's greater than 1, converges. If it's less than 1, diverges. Test fails if L is equal to 1. D'Alembert's ratio test and p-test are similar. If L value is greater than 1, convergent. Less than 1, divergent. Please remember D'Alembert's and auxiliary. A auxiliary and A D'Alembert ratio test are same. If L is greater than 1, convergent. So blindly you follow that. So in this case, see here, mostly in each and every question there will be factorial. See here, most of the questions there will be factorial or and so on. See here, and so on. So we have to use it as un and we have to write another u plus 1 and we have to divide. If the value is finite value, it is greater than 1, we say convergent. If it's less than 1, it is divergent. See all the questions and so on. If it's un, you have to make un plus 1. So the cancellation will be easy, and all these questions here 1 plus x square and so on. See here, most of the questions we have x here, x combination here. See here, so this is x square, x cube and so on. This is n square by 2 power n. This is how we have to remember. In most of the questions I have identified the factorials and so on. And see here, if you look at these questions, see here, most of the questions according to the D'Alembert's ratio test. So we have to apply. So this is x combinations are there. So this is also x to the power of 2n minus 2. And this is also and so on. So if this is there, like mathematical induction problems, we have to use D'Alembert's ratio test. This is 2 power 2n, this one. So in this case also you have to take the next step of s un plus 1 and we have to cancel. And this is also, see here, and so on and factorials or x combination will be there for most of the questions. These are all the questions from the textbook exercise problems. So exercise, see, look here, in which case we have to apply D'Alembert's ratio test. If we have factorial or x combination problems or like this mathematical induction problems, we have to apply the D'Alembert's ratio test. And one more thing, D'Alembert's ratio test and auxiliary series test or p-test are same. If L greater than 1, blindly remember convergent and rest are divergent. And the next one is Cauchy's nth root test. So look here, if un is a series of positive terms and limit n tends to infinity, un power 1 by n is equal to L. So here this is quietly different. C of A, B, C. So C is different. Two A's are same and C is different, reverse of it. If L is less than 1, convergent. If L is greater than 1, divergent. The test fails if L is equal to 1. So A is auxiliary test is different, D'Alembert's ratio test is different, and this C, it is reverse of it. So the next one here is, so it is power 1 by n. In order to get cancelled, most of the questions will be power n. See here, this is 2 power n, this is n square, this is minus n square, this is power n, this is 1 by n power n. So this is also power n. So if I make 1 by n in the as power, so it will easily cancel. So this is also power n. So in this also the last one is power n. So this is minus n square. So like that, n square. So this is n square, x power n power n minus 1. So these questions, these are all the questions. Maximum you just refer the textbook whichever you want. So these are all the questions I have taken and wrote in one session for a clear understanding. So if they are mostly parents, so we have to use this Cauchy's nth root test. So don't get confused. If you look at these questions, you will get an idea. And the next one is an integral test. So Cauchy's integral test, what it implies? So the improper, this is an improper integral, that is integral 1 to infinity f of x dx. If it's a finite value, then we say that it's convergent. If we get an infinite value, we say that it's a divergent. So straightly they'll ask, use integral test, use integral test, use integral test. So there are only 3 questions. So this is log, and this is 1 by n square plus 1. So these are the questions from the textbook which we have to use Cauchy's integral test. See here, and the next one is the most easiest one, alternating series. So a series whose terms are alternatively positive and negative is called alternating series. So we have a positive value, positive, negative, and so on. Then we say that it's an alternating series. So for alternating series, we have to apply Leibniz test. So what is this Leibniz test? It should be decreasing function and the limit should be equal to 0. If A and B satisfies, then we say that this alternating series is convergent. So we don't talk about divergent. So here, what is the Leibniz test? If it's a decreasing sequence and the limit un is equal to 0, then we say that un is convergent. See, look here. So this is minus 1 power n. So this is an alternating series. Definitely we have to apply Leibniz test. So this is plus minus and so on. So this is plus minus and so on. This is also alternating series Leibniz test. Alternating series Leibniz test. Minus 1 power n minus 1 is also an alternating series. So this is alternating series, and here cos n pi. So we know that cos pi. So this is cos 2 pi, this is cos 3 pi, and this is cos 4 pi, and so on. So here it is minus 1, this is plus 1, this is minus 1, and this is also plus 1, and so on. So this is also alternating series, and we have to apply Leibniz test. It should be an increasing function and the limit should be 1 by infinity. It is obviously 0, and according to the Leibniz test, so if we say that this is convergent. So this is plus minus and so on. This is also Leibniz test, alternating series. So this is the way we have to remember. We have to apply for every alternating series. We have to apply Leibniz test. And what about this absolutely convergent? The series un is said to be absolutely convergent. These two are also for alternating series. So for alternating series, if un is said to be absolutely convergent, if modulus of un is convergent. So here these are alternating series, negative, positive, and so on. If we apply whole positive values, then that is also convergent. We say that sigma un is absolutely convergent. So if this un is converges and modulus of un diverges, then we say that sigma un converges conditionally. So these are all the tests, and if you go through this video for 1 or 2 times, then you will get a clear idea on applying which test we have to apply on which problem. So hope you got a clarity. See, first of all, if un is very plain in terms of n, then we take comparison test and auxiliary test. If they are unsons and this one, what is this one? So if we go through the D'Alembert's ratio test, we'll be finding this factorials and unsons. And the next one, coming to the Cauchy's test. Cauchy's n through test, it will be of par n's, and the alternating series will be of plus minus and so on. We'll apply Leibniz test, and integral test it's straightly asked. And the next one is absolutely convergence or conditionally convergence. So this is from my side, and if you have any more doubts, please I'll make another video for you. Thank you so much.